the follow-up on.
Of course. Take it away.
Yep, thanks. So yeah, this is a follow-up on Panhelio with some new ideas on how to maybe work it into community practice so it actually becomes useful, because without community support, it's useless. So I think last I presented was about 6 months ago. It naturally follows up from that previously recorded presentation. So with that, let me make sure I got at least the demo kicked off here so I can actually show you guys something. But for now, I'll just go to a slide deck and actually verbalize what is going on with a bit of a reminder on what you guys may have seen from before. Right, so Panhelio, the idea is it's an ecosystem for streamlining heliophysics science and space weather operations to research to operations. So really forming that role across the NASA, NOAA framework, as well as DoD. They have their own sort of proving grounds, which is CCMC's role on the R2O framework, and then SWPC has the test bed, and generally TRL level 5 for the CCMC test bed, and sorry, the CCMC proving grounds, and then 5 through or 6 through 7/8 is the SWPC test bed, and then DoD basically has the mechanism to fulfill both the proving ground and the test bed within their own ecosystem for obvious reasons. So with that, just as a reminder for what the key takeaways are for Panhelio, it's an ecosystem for collaborative and repeatable heliophysics data processes, science, and forecasting. Why? You want to bring state-of-the-art data access and analysis to state-of-the-art heliophysics data to streamline science. How do you do this? You have APIs, you have database and a collaborative system using some of the technologies listed there on the right. All of this really isn't a surprise. External catalog and files, support a variety of metadata, taking it, under those things, right? And you can even consider the second from the bottom there uses additional libraries, tools, data, and models. That includes things from HAPI to the PyHC Python libraries that are that Sean just mentioned, new ones, old ones, improved ones. So all of that sort of bundled into an environment that can go where you can do data fusion. I think that's a critical thing that we really need to be able to do in cloud virtual capabilities like this. You don't want to just create something for one user. And generally, if you introduce concepts such as streamlined data fusion, streamlined machine learning, analysis ready data, you're on the right path, at least in my opinion. And it's AWS GovCloud hosted. This is also critical for the convergence of roadmaps and architectures, right? If you develop something that is going to have an architecture, so for instance, HDRL, which is being formulated by Brian Thomas, Aaron Roberts et al. All of this stuff can hopefully converge in some, understandable process. You know what is coming around the corner from various groups, including the DoD and NOAA as well. And so you create something, at least Panhelio in the concept, would create something that really can go across and be useful for multiple communities, but also borrow concepts and things being such as GRL, the Heliophysics Digital Research Library, as I understand. So anyways, just a reminder here. And then, of course, going to have a architecture for this. Again, data in from the left. We have an operational ingest. We focused on GOES, ACE, Discover for obvious reasons. It's good, lengthy space weather foundational data set, as I like to call them. And 3/4 solar cycles for flares and SEPs going on. It's about 2 cycles for ACE and Discover. So it's nice. So you ingest those scripts, you run event detections on those in situ data. You can put the measurements along with the start and end times of those events into a database, and then you can make all of that data really move. By really move, I mean make it analysis ready. Again, I emphasize this again and again. I don't understand why this community has not formulated sort of a scientific crowdsourcing of these events. This event is associated with that event, etc. So that's definitely one of my foot stomps here. Should be over where, you know, we read papers and just say, yep, okay, this person has a catalog, and I have to reach out to that author, or I simply scan it in and have some sort of word recognition, you know, catalog that stuff for making it as analysis ready as efficiently as possible, right? But that makes things like if you have the start and end times for flares, etc. And furthermore, you have event associations, this flare to this SEP, to this CME, to this shock, to this GIC, whatever, on and on. You really empower the user to use that start and end time and those associations along with a database that has the raw data itself. And then they're able to use other APIs, go out and reach out to them. And so you're really given the users the effective tools to search, you know, more with a fine comb, I suppose, but maybe not even at a fine level. But that's critical. I don't understand, you know, well, I do, but that is something that needs to happen for this community to be really effective and analysis ready, because then I can start in time for some data access, either through the space weather data portal, or HAPI or PySat, right? I mean, if you have those start and end times for some of these foundational data sets, you can really move quickly in terms of what you need to organize for your particular science effort or even R2O, and understanding data temporally as well as important, you know, what's real time, what's not, and what is considered real time and what is not, for research to operations in particular. Alrighty, so again, this is borrowing heavily from some concepts of Pangeo to Panhelio. So Pangeo goals, you can see there, are above. Panhelio goals really mimic those at a high level. So foster the collaboration of solar, interplanetary, magnetospheric, ionospheric science, support the development with domain-specific helioscience packages, and that's really PyHC's role. And so borrowing what's already been done there and making those packages more effective, again, tooling up the users without the complications of building their own environment, because you've already got that Python kernel or binder or notebook or wherever, so they don't need to worry about spending, you know, 3 to 4+ hours on setting their environment. Moreover, the environment will be the same as their collaborators. So again, another streamlining way to hopefully reducing that 40 to 60% cited for data wrangling and things like that. And again, that's what HDRL is working towards, so we can borrow those fleshed out concepts that folks like Jack and Brian are working on. And then improve the scalability of these tools to handle petabyte scale data sets and figuring out mechanisms and procedures for work. I believe that's probably not a static thing as well. It's constantly in flux. You know, what data is actually accessible in an S3 bucket versus what's in Glacier, what you need to request, and providing those sort of procedures for the users of Panhelio. But Panhelio is ambitious. So how can you reduce risk? And you can look at reduced risks such as how does this get adopted by the community, while still being ambitious and useful for the community. So let's dive into that for a moment. All right, so on this diagram, on this bar chart here and pie chart, these are the recent space weather and O2R awards. On this graph is about $30 million in the past 5 years invested into the space weather research to operations community, right? And you see, you know, Boulder area has done exceptionally well with getting awards from the Space Weather Quantification of Uncertainty Awards, as well as the Roses are. Right? And then you see a variety of other institutions here that have gained those awards, but roughly $30 million, that's a lot. And most of these awards, this is a plot that's been shared by people both at NOAA and both at NASA. So there's an agreement for how this framework works. And you can see the CCMC logo there. That's their readiness level 5 to 6 transition, where they make the selection for demonstration. And then you have selection for operational transition done by NOAA SWPC testbed if you see what is being validated by the CCMC. But readiness levels 1 through 4, they don't really provide any on-ramp to, in particular, the CCMC environment, right? Most of what I showed you on the previous plot, with the exception of some, most of these efforts will end at 3 and 4, and 4 is being a little generous, probably in most cases. So then that must mean we have a valley of death, or as Jim Spann and NASA are calling it, a transition step gap between readiness levels 4 and 5. So how can we do that? Well, I mean, maybe we want to shift gears on Panhelio a little bit and focus on this particular community in the heliophysics area. A lot of people are interested in making better forecasts and predictions, right? So that could be a goal of this Panhelio. It gets you a little bit more focused. And so on that, you on an environment that streamlines space weather science and applications, as opposed to out of the box, we're going to be useful for everybody in heliophysics, right? The idea here is if we focus on space weather transitions and operationalizing these TRL level 3, 4 capabilities, our user base becomes that much more focused in setting up what we need to do for potentially the PIs and collaborators of all of these projects. So we want to enable space weather abilities to survive the valley of death too, right? I believe long day over where capabilities are built up on local servers at university or labs, having this type of visibility across the field, IP sort of set aside for the moment, it becomes just a better science working capability. And then of course, you want to fuse R2O standards with these space weather capabilities, right? Sometimes it's hard for scientists to understand what goes into making something that can at least be transitioned by CCMC. And so you would want to build up so you could match more or less, for instance, CI/CD pipelines, introduce agile developments for the scientists. Like, hey, for instance, if you guys follow this 10-step process in an agile methodology, you will have a TRL level 5 capability. And then CCMC can take a peek under the hood of Panhelio that's focusing on the space weather R2O and say, yeah, that looks good. I'm interested in those metrics. Like legitimate metrics, that could be exactly what we want to look for. And so that it's sort of a lot of time saved on communicating via email. As I understand it, it does seem to be a bit of a manual process, from JSON schema to just getting familiar with what is needed. I do understand there are roadmaps and sort of steps that CCMC is gearing up to provide the community with their beta cloud. But if anybody knows more better than I do, please let me know. And then of course, fostering the space weather enterprise collaboration, because again, this is where a lot of the research dollars are being focused on ever since the ProSwift Act and Swarm and things like that. So it is a good opportunity as well, because it's a focused group within heliophysics, even though it spans all of the physical domains from the sun to the mud. But again, you gotta start somewhere. All right, and so here, community benefit. This is some not fully fleshed out, but minimizes data efforts to do data wrangling, again, with the support of ongoing efforts here. Happy what NOAA is endeavoring to do with NCEI and things like that. And we want to maximize the science and really the applications as well, from all the way basic through proof of concept and doing it in a lab environment. And really effectively, it's getting at trying to do an on-ramp to the proving grounds. And so you can remove a lot of that, hopefully some of that communication coordination that needs to take place, which can be very time-consuming, not necessarily ideally where scientists want to spend their time, right? So it's all about reducing the time spent on how to get your work done. And then it builds on a lot of, again, what Pangeo and PyHC is at. It's like, this is gotta be open source and sustainable. So how's the best way to do that? Open source is a good way for sustainable. So a little bit of saying the same thing twice there in different ways. All righty, let's see here. So the goals, right? So if you remember anything on what R to O to R could be, it's develop capabilities that address R to O to R infrastructure, standards and processes for TRLs 1 through 4 to streamline space weather data, software, and models for validation, operational transition, and utility. And it does this by the following points. Again, hosting and accessing data, they both have their pros and cons. Supporting a variety of users. Again, if it becomes more community driven, the better, right? If people pick it up and run with it, that's exactly what you want to get and provide for the community. Is something they can own. Foster collaboration around the open source, mentioned that. Support development with domain specific helioscience packages, again, mentioned that, just worth emphasizing. And scale these tools to handle petabyte scale data sets on HPC and cloud platforms. And then last bold bullet there, or point, is the complementary capabilities designed to Pangeo IO. That's the website. You can go there and check it out if you're generally unfamiliar with it. What's going on with NASA HDRO, what's going on with what Rita called out at all with the diaries system. So they're all things that it can align itself to and borrow concepts and ideas from and whatnot. So I just wanted to go through that. Sorry if it was a little quick, but I sure don't want to take up the full hour here by any means. But after this, I'm going to shift gears and move on to some of the stuff we've created with what is basically the kernel of at least our Panhelio concept. Sort of specifically calls out space weather research to operations in what we applied it for. But again, it's about making it extensible. But let me pause there for any questions or comments, and I can run back up the slides.
I know Rebecca left a comment in the chat and there's been a little talk about it, but she asked, why is model data going through space weather check?
Oh, it's a good question, right? So I'll speak sort of on that point, on what I think is, at the real core for the issues for the space weather community, right? There is data's hitting the floor at NOAA SWPC, and this includes basic things, or at least hard to find things, such as the NOAA SWPC 3-day forecast, which is a joint forecast with the DoD. After 90 days, it's very hard to find that data. I actually don't know if I've found it. But how can a community be expected to prove itself by saying we're better than the current state-of-the-art forecasting? For instance, KP forecasts by NOAA SWPC. It's an unfair question. You can't really do it if you don't have access to the model output. And this includes other models such as WAM IPE, Carry 7, and the geoelectric outputs from Chris Balch's model, right? So again, if that model is not accessible, how the heck do I compare my forecast with what is outputted by those current operational predictive models? Right? And the answer is you can't. And so there's I believe a disconnect, although I have talked with people at NOAA SWPC and see is why is this data not readily available? We're getting asked by, really coming from the pro-SWIFT language on focusing on improvements of forecast. And you don't know if you made an improvement until you have the operational data outputs. Doing really all we can do today is model comparisons, because actually nobody has a lot of time to do model validation and verification. And so, for instance, there's an ongoing effort for SEPs, and really it's a model comparison. And it's difficult to do model comparisons because what data did you use? What did you validate it against? Were you using a different GOES X-ray measurement that wasn't the prime instrument designated by NOAA SWPC? And that happens quite a bit. So anyways, that's sort of my observations for what is a real problem for the space weather community. And you know what you can do? You can virtualize the NOAA SWPC data products. Resources provide, meaning RAM IPE is a good example of a model that's huge. Since going live last June, July, it has about 7 terabytes of data. Doesn't sound like a lot, but you know, if you use cloud resources, that's probably a couple grand to 3 or so if you want to keep it in a relatively active data, like an S3 bucket or something. So anyways, that was sort of my comment there. I know it's not directly asking why space weather checks holding model data, but therein lies, you know, some like, hey, maybe they're holding on to some data sources that are, you know, hard to find, and they're doing a better job of keeping model versioning, because I know that's another issue. We've had, you know, Magpie has had multiple versions across multiple institutions, from CCMC to NASA SHRAG to UAH, where the model originated. Same with NLIL, same deal, multiple model versions all across the community. How can we be expected to know which we should be comparing against? So it's a difficult thing, but addressing it is, well, let's make as much of that data as possible virtualized. So we can either bring our model to it in whatever cloud platform, Jupyter Binder, whatever, and work it that way. But yeah, I'll pause that ramble here for any reactions.
Well, thanks, Alec. That question was honestly more to the Colorado Boulder people rather than you, because they're the ones that have the Swix checks idea. But
yep,
thanks for the answer.
Yeah, you bet. I didn't know the context. Thanks.
That's fine.
Alrighty, if nothing else, I'll get to the screen share here. So shifting over. All right, so I think I showed this last time, but it's just to remind us, you know, what these flare detected events. I think we're showing every flare detection in here above a C3 or something like that. And this flare was actually detected earlier. I don't know why it's not showing up right now, but you have flares, protons, and solar wind measurements here on the bottom. 4-day forecasts, you have NOAA SWPC's predictions, N for NOAA for X-class flares, and then M-class flares right there, right above the crosshairs. And then you have their predictions for solar energetic particle events right now. This event here, for instance, it has reached both the 10 MeV, 10 PFU threshold, which means based on these 1% forecasts that these are probably missed events. And actually it looks like we have a very low probability for these to occur. This is roughly an M7. Yeah, so there it is, M7.4 for this flare event. But again, all of this goes back to 1986 for flares that are associated to SEPs. And now again, you're tooled up to go out and identify other events such as radio bursts, and you can search like, hey, my flare started at this time and ended at this time, and then I had an ongoing SEP event. Was there a radio burst event, or maybe I can just pull in that radio burst time series data and start to work with it. So again, that's the event associations, I think, are really key for the space weather community, as well as the virtualization of actual operational model outputs and getting access to them. This guy here, is real-time AIA. Again, you can tool up this dashboard to however you want to look, right? Open source, go ahead and look at this modularized code. Hey, I want to look at SUVI instead, because that's truly the operational EUV instrument. It's not AIA. And then LASCO, as we know, a lot of scientific instruments are being used for operations in some cases. So yeah, and then there are the data tables and things like that. Before switching to another guy here, 2003 Halloween storms are always fun to look at. So I'm just going to enter this in and hit return, and then jump to something else for the moment. Right, so this guy, right, along with that time series dashboard, which is very, time window constrained, you have other capabilities for exploring the data and understanding, what does data look like? What are the event relationships and patterns that you might be able to find? Analysis ready, machine learning ready, etc. And again, we focused on the goes, ACE, and discover because those are what are used in operations and do have that long period. Here you can see that there are 4 solar cycles on this guy. You can see every flare that was associated to an SEP event has this sort of green to red spectrum here. You can hover over these plots, jump back to the time series, and check it out more in detail, right? So more of a high level view of data relationships and things like that. Understanding data patterns, and that's where something like this can come in, simple 3D plot. Blue circles are flares that are not associated with SEPs. Green to red are flares that are with increasing flux here. And so you can see the Halloween storms. Oh, sorry. There's the Halloween storm there of that particular one. The 1989 event is a big one too. And you can see them shown with some of the flare metadata that we thought would be helpful for a machine learning capability. So let's see. Let's get rid of the feature out of the way. And here, parallel coordinate plot, you can see event relationships really easily. Again, multi-dimensional. This is probably one of the better ways to do it. If you're looking at multivariables that get fed into a machine learning algorithm or a statistical one, just to understand all this one. So flare ratio along the short channels seems to group up a bunch here. So highlight those. That looks cool. The decay phase, I don't know. It looks pretty well mixed in with some of the blue lines there, which again are the flares that are no associated SEPs. Here on longitude, there appears to be some good clustering of some of these events. So I'm just going to select this right below this red event here, which is probably a large SEP event upwards on this guy. Flux seems to do decently well. So I guess I'll select under this red event just as an initial concept. And then fluence, looking at fluence, it does quite well. It's probably one of the best parameters out there other than longitude and ratio. So let's take a look at that and highlight some of these. And so now you can see we're starting to entering in, predominantly flares that are associated to SEPs. But we still get in that mix of blues here. So there are probably other metadata types we can look at. So before jumping back to the time series plot, I just wanted to show this because this is really cool. What we've done here is use the intake library and just simply the HV plot library in Python. And you can see NumPy is imported as well. So 3 libraries are. And that's it. Looks like NumPy is imported twice for some reason. But as we see here, this is accessing this capability right now on the cloud. Our cloud, NextGen's cloud, is accessing another cloud for 400 gigabytes of SDO data for one day, covering, I believe, all the wavelengths. And I don't quite recall the cadence, but you can figure it out. 12 seconds, every 12 seconds, an image, and all 7 channels here are taken over the course of a day, and so resulting in 1,800 instances. And then you can do the math for however many they took. Maybe they only took one every minute or something like that, or one every whatever it is. Maybe they did do one every 12 seconds. But here's the calculation of the gigabytes. So again, it's roughly 400. And then you can literally scan through 400 of images you just accessed using critically the intake library here. But there are other interesting libraries that are coming into the fold, like Kerchunk. You should check that one out. But this makes it, hey, I may not have storage in my cloud to do this, but at least I'll have access to it. And if I scan through the day here, it takes about, I would say, anywhere between 30 and 60 seconds for this particular image that we requested. And it looks like it's only part of the day. As you can see, I'm only at 3 UT here. And so we can just see, and it goes to, looks like 6 UT. So this is just a fourth of the data for the EUV images from AIA. But again, you can see in the upper right, this black circle, that means it's working. Intake is doing its thing to gain access. There's an example notebook of this, that this is basically what Anaconda developed. I think they had a request from from NASA HQ or somebody at NASA to take a look at some SDO data. Anyways, it's a really nice way to get lots of data, not quite analysis ready, like having it on your own data storage, but still pretty nice. So there, you finally saw that rotation, maybe it just blinked in front of you. So it took about 60 seconds, I would say, maybe 45 to do that. But could be more useful than trying to download it yourself, right? And maybe you have sharp bounding boxes, which are really convenient bounding boxes around active regions. And so you can say, hey, I got this bounding box for the sharp. I basically want to put that bounding box for this active region to access this data, thereby reducing a huge amount of access volume you would need to get at the active region you're targeting for whatever purpose. And that itself could lead to creating sort of an ML ready process, as opposed to, actually having ready data. And then you create more manually the ML ready data from, combining the procedures of using sharp bounding boxes along with this intake for AIA data, to create your process on streamlining, creating an ML or analysis ready data set. All right, last guy here. So you can see I updated to go to the Halloween storms. We don't have historical forecast for this guy. As you can imagine, the SWPC 3-day forecast, I just can't find it easily enough. So I need to talk to somebody like Hazel Bain, who's been on that. And then if I click on this nice flare here, you can see that for the user, it shows up as red and the associated event shows up red. And eventually you would want to, again, do this for all of those, again, foundational potential data sets, start and end times of shocks and CME structures, and things like that. So I think that's all I wanted to say. But again, the idea, I think, in focusing on space weather research to operations from the sense of this pan-helio concept could be a good way to get good field. You saw how many institutions are actively involved in research to operations, at least on the science side. And if you do this for the community, maybe this is, one of the first places they can see like, hey, does this have the functionality and data access that I need to make work? For instance, there's huge advantages in having these observations data-based, right? Using intake for them maybe not what you want. You want to have them data-based and furthermore have these event associations to go along with them. And it isn't that big for this. I think we have about 500 gigabytes going back to 1986. And so some of these data sets, such as these in situ ones, are a good place to start. But yeah, with that, I know I probably chewed up there just about 30 minutes, but happy to discuss or answer questions to the best of my ability on this and make any clarifications. So thank you.
Thanks, Alec. Anyone have any questions on Pan-Helio updates, anything there? If not right now, and you think of something later, I'll include Alec's email in the notes, so you can always reach out and ask about anything then. Thanks for giving us that update, Alec.
Yep, no problem. Thanks for the invite. Appreciate it.
Of course. Rebecca looks cool. I agree.
I have a quick question, actually.
Go ahead.
So you mentioned right at the top about unconnected events. Can you say a little bit more about that?
So is it okay if I talk about associated events there? Or
yeah. So well, yeah. I don't understand what you were driving at. Associated events.
Right. I think so if you have multiple associated catalogs and individual catalogs, detail on whether it's a remote sensed catalog or things like that. I think once you have start and end times across multiple space weather events, heliophysics events, is extremely helpful for using other access capabilities to reach out into other data sets that you may think could be important for your effort. And so if for instance, I have a start and end time of a flare that's associated with the start and time of a SEP that's associated with a start time of a shock, and I say, hey, based on this catalog, and I can feed it into, you know, a capability like HDRL, right? And I say, hey, I have all of these start and end times going back to 1986. I'm going to give you all of these start and end times across all of the events. And on top of that, I'm going to say plus or minus 12 for those events. And you say, I want to look for type 3 radio bursts. And you put that into somebody's capability, like HDRL potentially, and it returns to you everything about type 2 radio bursts that are in that or overlapping with those times. And you say, great, now I'm going to hit a button for all of those type 3 radio bursts. And now I'm going to get access to them, or I'm going to be able to do a view of what is available. And somehow, hopefully with not too much manual process, identify what I actually want to bring into the fold of these associated data sets. And so you get the raw radio burst data, say at the start time of a flare and the end time of the CME shock that is predetermined by scientific crowdsourcing to be associated with each other. And then you get that time series of the radio burst, and you can say, you know, I got X thousand number of radio bursts. You can apply I know there are a couple of computer vision machine learning algorithms that determine the start time of the radio bursts. And so you're able to apply those packages somehow to get at the start and end times of the radio bursts. And then an additional step, again, you know, this is still manual potentially, but it is removing quite a few, I think, hands-on steps. So where is the radio burst? You know, the multiple areas that can be looked at potentially. Once you have that, though, now your associated catalog has introduced a new type of event with new metadata that you've calculated, however you calculated it, and now can be introduced to like, hey, I got flare inputs. Now I have radio burst inputs to predict SEP profiles or events or time of arrival of the shock at L1. And so that's what I'm sort of driving at there is if you can have this guidance on start and end times of events, it makes searching for data, provided that those functionalities are in place in whatever database or repository or API you're looking for, that much easier and concise, targeted, really. So Jack, does that make sense? Or, you know, I'm really open to thoughts on that, provided you understand what I'm putting down, picking up what I'm putting down.
No, that makes sense. Just as you were talking, I was thinking that you could imagine like in a science paper. So a lot of science papers would do this kind of thing that you're talking about, right? That's part of scientific research.
Yeah.
But if there was a way to just extract the connections made by the scientists in the paper just as a data set by itself, then that would be extremely powerful going forward, right?
Yeah, I agree. And that's why I think actually maybe some of the most, yeah, right. So you can think of, let's say you had the ability to scan every paper in Space Weather Journal, in AppJ, and say, look for tables in particular, either in the appendices or in the paper themselves, scan it, apply sort of a PDF data table converter to a pandas data frame. And then you are able to identify, hey, this is a event type here that they've identified in this catalog. But now I've seamlessly, you know, applied this, you know, data translation into a pandas data frame. And now I can work with that as well. And, you know, even better, it comes with a reference peer-reviewed paper. And so that could be, you know, it makes sense. That's sort of my reaction to what you're saying. It'd be very cool to be able to do that sort of capability to augment, you know, more of this manual process, or, you know, this automated detection event, which does need improvement on top of it. But, you know, those start and end times can also be helpful for machine learning, for identifying an event as the human eyes observe, like, that's definitely an event. Look at that. It's clear up and it's clear down. Maybe stop and end isn't totally there, but anyways, Jack, I'll keep rambling on that.
Right. No, I hear what you're saying. So
okay, cool.
Thanks.
Yep, thank you.
Awesome. Thanks again, Alec.
Yep, no problem. Thank you.
So the other topic for today, in the time we have left, Russell mentioned wanting to bring up recent responses to RFIs a little bit ago. Russell, would you like to elaborate on that a bit? If you're talking, you're muted, by the way.
Thank you. Yeah. Is it coming across now?
Yeah, you're good.
All right, great. Thanks. Yeah. So some sessions back, I brought up the SPD 41, which is a set of rules that from NASA, from SMD, kind of on how data and software is supposed to be treated if it's funded by NASA. And then those rules are in the process of being changed, or there's a proposal to change them. So then NASA, as part of its process, had an RFI, request for information about it. So my general understanding of the general process, at least for the United States government, whenever an agency is changing its rules, is that the agency is supposed to let the public know that it's considering changing the rules and how it's going to change them. And then there's supposed to be a period of public comment. And then the relevant agency is supposed to go through and respond to all the unique comments, and that they can go through and group similar comments together, right? That way I don't have to answer the same question 100 times. And they're supposed to issue a community-wide response. So, whoever responds to it doesn't get an individual response, but the content of the response is supposed to be as part of the agency response. And then, in principle, the agency have a response anywhere from thank you, but no to your comment, or they can say, thank you, and we're going to change what we're doing because of it. At least according to the rules. So what are some of the changes to SPD 41? So I didn't include all of them. If you were aware of this RFI, it listed all of the specific changes, but I just pulled out a few of what I consider are the notable ones. First one there is the SMD funded data should all follow the FAIR principles. So it should be findable, accessible, interoperable, and reusable. So that's great for data. So anything that's, publicly funded, that data has to be available for everybody to use. That's already kind of been in process. I'm not sure it's exactly been the FAIR principles, but the data has been public. A more significant change, I think, at least it's on the hardware side, is that the mission software now has to be publicly accessible software. So I think that's probably going to be a challenge for some of the institutions, or at least they're going to say it's really a challenge. They may not want to do it because it's going to require them to open up some things that they've previously held as proprietary, and kind of keeps other people from doing the same instrument. So at least I'm pretty excited by that coming out.
Some other things there, and sorry, Russell, this is John B. Can we pause there and just do a quick survey? What do people think about that? I'd be interested to hear, because some of that would be actually pretty difficult to expose, and it may not be. It depends on how you interpret what mission software is, right?
This is proposed. This is not.
Yeah. No, I understand. Yeah. So, science pipelines, sure, but mock stuff and telemetry processing and bit busting, I think that's not appropriate. That's my opinion. So I'm just kind of throwing that out there and see if, Russell, what do you think about that? And then others too.
Well, I think more of the software that can be available, the better. I mean, the Icon IVM software that I developed was built on PySat. So that one, I'm not involved with Icon anymore, but I mean, that one, it's certainly possible to do instrument processing on public software and put it all out there in the open. And I think that's actually a really crucial thing. If the community or the public can't establish how the raw measurements are actually translated into science parameters, it's hard to establish trust, I think. If you're getting into parsing binary files and things like that, it may not be the most illuminating to look at, but at least having it out there prevents, I think, claims that there's, something nefarious going on with the processing.
I mean, there are other concerns too with giving some of that away, because
Yeah.
some of our, I saw this in one of the other responses, but that, some countries are very open with how they share stuff and other countries are not. They just take what we do and they
Right.
leverage it for themselves. And so,
That's right.
and they never even, they don't even share data, let alone software. So
That's right.
it's, we need to keep that in mind as well, that if we give this away, I mean, I'll just speak freely, I guess, that, China
Please.
is always taking stuff
Right.
and they don't share their data even. So I don't know how, there's no easy answer for that, but
No.
it's definitely a concern that we're giving away all of our technology to people who then, I mean, it's kind of just a national prestige thing. That's why it was
Sure.
pointed out in this one white paper that we'll fall behind with that if we just give it all away. So I totally agree that having this open and be believable is good. And for trust, we need that. But there's all these other concerns too. Plus some of the software that people use for those low level processing things, they pull it in from everywhere. They're pulling in proprietary pieces and because that helps them save money. And so
Sure.
there's maybe an increased expense to it all. So
There could be, yeah,
it's-
certainly. The
yeah,
first
it
one.
gets complex fast. And the way
It
it
does.
was presented in the SPD 41, I think kind of swept some of that complexity under the rug and said, hey, this is great. It's all open. And it's like, wow, this is going to be very messy, especially at the beginning.
That's why they put this out, and I think they purposely put it out in a fairly provocative way to see how people push back.
Mm-hmm.
Yeah, I didn't push back on this one at all because I am in favor of it. I was surprised to see it though, and I didn't see any mention of ITAR or anything like that.
Yeah, well, they say all
restrictions
ITAR
on the
stuff
that goes out. So
Mhm.
There is a disclaimer about the ITAR. in
Oh, is there?
different
that was in there. They said if it's ITAR, we don't claim it.
Okay, all right. I must have missed that when I just reviewed it again. Thanks for the clarification.
Mhm.
So yeah, so I expect there's probably going to be some debate on internally too, and some of the responses. So some other things I thought were particularly important for our community is during SMD reviews, peer-reviewed data and software shall be recognized as having the commensurate values peer-reviewed manuscripts. So if we have software out there that is peer-reviewed, not defined in the document, but that's the same as having a publication in a journal. So that's a really significant step, and I think it's incumbent upon us as a community to make sure our software is up to that standard. Can say that the software is science, and for the authors that produce that software, that should be reflected appropriately in grant reviews. And then also the document says that SMD funded software should follow best practices in the relevant open source and research communities. Again, so that's not defined, but I guess that leaves it for communities like us to define. So just a note to ourselves. I think we should sort out our application of standards and enforcement of best practices. So right now we have some standards for code and their signatories among the community. And then we have the project list, and it lists whether or not packages meet or partially meet those standards. But there's also a lot of packages that don't have any entry at all. So I know that list has been there for a bit, but I think it's might be time for us to start getting a little bit more enforcement on that list. That's a topic that I'm planning on bringing up during the spring meeting. Okay. So for my response, technically, so NASA is supposed to publish, the things that it gets after removing identifying information. So, I could have just put in my comments and never said anything and then, whatever. But because I brought it up and originally about the document being changed, I just thought it'd be good for me to be open about the things that I put in. So I went after just two things. One is that data providers should be prohibited from requiring user accounts to access science data. So this is actually a challenge that the PySat team ran into. We spent a lot of time building up access to a data set only for that provider to then apply user account requirements, and then we got kicked out. So it was kind of an unfortunate loss of not only getting data access out there, but loss of time and effort. And then the second one is when I first brought this up, I kind of suggested that the changes actually implied that NASA had to start paying for more of this stuff. But it wasn't explicit in there. And that was a comment I heard. So then I formed my argument to why those types of things should be explicitly included in the document. So started veering off a little bit into legal stuff. But it is like a page for each of this, a page for this response, a page for the other one. I just tried to distill it. But generally speaking, the rules from the government prohibit charging users something of value to get access to like this SMD data. And some places do have user accounts that are required to get on there. And I argue that having a user account is requiring something of value. One is requiring user time. They have to have secure, password management and all that other stuff. But also the government agencies value that user information in and of itself. They want to report metrics. So the people developing the system, they want to collect all the unique users so they can pass it on to the government. And then the government can be like, yay or nay, we did well or not. That's value. So, I get that the agencies want to track use, but that doesn't mean, you don't always get what you want. There is an exception that agencies or whoever are allowed to charge the cost of serving data. So I pointed out that places like NSF have no user account, are able to serve data just well. So user accounts aren't really a required thing. It's not something that you have to have. This isn't something I put in there, but that cost of serving data has also been abused or misused by different agencies in the past, notably like for the justice system, which charged a lot for access to legal documents, and the justice system then uses those funds for things that are completely unrelated to that. So if we start allowing costs for science data, things can get out of hand quite easily, and that's not good. This one is probably don't have the time to go through. Like I said, this was a page response and I just I try to condense it very much. But this top part here is me arguing to NASA, hey, if you're choosing open source to distribute science software, that's great. But so open source software actually has a cost to maintain. So if NASA is going to do that, then NASA's already selected, open source is something that needs to be funded. I would expect that NASA would say yes, but no. So the second thing is me trying to get ahead any responses they might have to that. And then here's just a couple notes. But the very quick summary is NASA selected open source as the platform to distribute science. That's great. If NASA selected a place like Microsoft to distribute something, then Microsoft would already be kind of getting paid. It is true that the license for open source software is free, but it's not actually free to develop. So ergo, NASA needs to actually start making sure that this previously voluntary thing is supported in a professional manner so that all the science and stuff can continue on in the future. And officially, the government is not supposed to discriminate based on business structure. So the fact that open source is decentralized is not in of itself a reason to not pay. That's kind of it.
That's a clever way of saying it. Yeah, can I jump in for a second, Russell?
Please, yeah.
Yeah, I mean, the way I saw this in the draft SPD 41 was at the very beginning of the document, like the second sentence, they emphasize the importance of data curation. Right? They say data can't just be archived; it must be curated, and that's an ongoing effort to make it useful. And they never said the same about software, but it's even more true with software. Throwing a bunch of open source software into a pile doesn't make a software ecosystem that produces where you can do reproducible science and shareable, development. So the curation of the software is critical. And so I think this PyHC community is a good example of how you could foster that with this sort of naturally gravitating to people that want to do that kind of stuff. And they need funding to get their software transitioned into an ecosystem that's coherent.
Yeah.
So that was in my response, was that you got to curate the software too. And you need to, look at what's being done grassroots that's working and reemphasize that.
Well, that's great. I appreciate that. Yeah, it's great. And, the standards I think are higher for open source software because everybody can look at the code. So you gotta you have to spend the time to make sure everything is, documented and tested and all that stuff and with science. So, and that's a non-trivial commitment. I mean, that takes a lot of work. We were just talking about that on a previous thing, like takes a certain amount to get to like 80% testing, but as you keep going up in percentage, it's more and more work. That stuff is, needs to be done, but it's not trivial. And if we want to keep that stuff going and have things that are well tested and well documented and all that, then yeah, we need, in my opinion, we need a better model than what has been applied to like the hardware missions. So,
and without that documentation, who is going to
Right.
use somebody else's software? You have to just,
right.
yeah. So that's a critical part of the curation is the documentation.
Yeah.
So I've disrupted your flow enough here, but
It's okay.
I just agree with you. I think this is great. And we put
That's
in
great.
4 white papers.
Well,
So-
I'm glad you're here. You sent that in. It's okay to interrupt. Great to have you back. Not a long presentation. We're almost out of time anyway. So just conclusion. I think the proposed rules are a really good step forward. We might be at the dawn of officials open source space science. I know people have been working here so for a while. I'm not discounting any of that, but now if NASA's saying everything has to be out there, that's a big step. And as part of that, that also, requires we operate with high standards too. So that's something I'm planning on talking about some more during the spring meeting. I think I have a session there that I'm going to be including some of this stuff in there too. So yeah, so thanks for the time.
Yeah, thanks, Russell. And I'm looking forward to talking further about this at the spring meeting. I agree, especially adoption of the standards and making sure all our projects are actually implementing them and at least putting grades on our page would be great.
Sure, yeah.
Cool. Well, it looks like we've run right up until time. Thanks everyone for staying a little later who was able to do so. And thanks again to both of our speakers. Our next Telecon will be Monday, April 11th, same time, same place. And we'll be having an HGEE project intro from Kevin Reardon, as well as another project introduction. It's not HGEE, but one that I heard about last week at ML Helio, PyHC. So look forward to that. See you all then.
Thanks, everyone.
Thank you.